Find the difference of the areas of two segments of a circle formed by a chord length 5 cm subtending an angle of 90 degree at the center. So first let's think about the diagram and then figure out what is that we need to figure out. Let's see. So my answer starts with the diagram. So we have here is a chord of length 5 cm subtending an angle of 90 degree. That's 90 supposed to be. This is 5 centimeter. We can call this as OAB, right? Just a second. That is convenient, right? Okay. Next is, they're asking us to find the difference of areas of the segments of a circle. That is, they're asking us to find the difference between area of major segment minus area of minor segment. Okay, so this is what we have to find. To find this, we need to figure out what? Well, we need to figure out theta, which we already have, and we need to figure out the radius. How will you figure out the radius? With the help of the length of the chord. Okay, so here we have it to be 5 centimeter. This is R, this is R. How can we find this? Well, we basically have a right angle triangle. To be specific, we have an isosceles right angle triangle. This is 5, and this is, sorry. This is R, and this is 5. So what will be R? Yes, we can make use of Pythagorean theorem, and we will be done. So this is our sequence of thinking. So first, using Pythagorean theorem, we can find the radius. Okay, so with the help of all of this, we can find the radius, and once that is done, we will be able to find the area of the major and minor sector difference. Right, guys? So let's start off with this is your line of thinking. So sequence of thinking. Okay, very first thing is what? We have to find the radius, right, using the chord and the Pythagorean theorem. So we'll talk about triangle. In triangle OAB, what do we have? We have AB square, or we can tell OB square plus OA square is equal to AB square. How is this possible? How is that we are able to tell this? Because of Pythagorean theorem. So what do we have over here? We have this to be R square plus R square. This is equal to 5 square. So this is your 2R square is equal to 25, or 5 square itself. I'll explain why. So we have R is equal to 5 square by 2, but we need to take the square root of both the numerator and denominator. So this is basically 5 by root 2 centimeter. Ideally, we need to rationalize this, but this is not the final answer, so we don't need to bother with this. We'll just keep this. Next is, this is done. Directly, we can find the difference between area of major segment, minus area of the minor segment using what formula? So we have the formula which is equal to theta by 360. Sorry, this is 90 minus, not 90, 360 minus theta by 360 into pi r square minus theta by 360 into pi r square. Okay, so here if I substitute theta is equal to 90 and r is equal to 5 by root 2, what will we get? Well, before this, I want to do this actually. See, this is one of the equations. Now let me write this way. This is one of the equations. This is one of the equations, right? In both of this, we have pi r square that is common. If I take pi r square out, what will we get? So we have 360 minus theta by 360 minus theta by 360 this entirety is multiplied with pi r square. Okay, that's what is happening. Now what is the LCM? 360. So we have theta by theta divided by 360 into pi r square. This step is not required. It's only for you guys to understand. So this is 360 minus 2 theta divided by 360 into pi r square. And at last we have 360 minus 2 into 90 by 360. This is 180 basically. This is half. So this is 22 by 7 into, see, 5 by root 2 into 5 by root 2 is same as 25 by 2, right? So we can directly write this as 25 by 2 because we have r square. That's why I told you let's not rationalize it. So 1s are 11s are. This is 180 clearly, is it not? So this entire thing, 1s are, 2s are, anything else? Nothing. And so we have the answer to be 14. The numerator you have 27 by 5 by 14 centimeter square. Okay, yeah, that's it. So you guys got the funda right. All we have to do is this, taking common. Don't just start substituting. It's of no use. It's going to be too lengthy. So this step is not required. Even to be honest, we can directly jump to this step. Even this step per se is not required. Taking common is important. If you want to do systematically, that's good. Nothing wrong in that. But you can directly jump to this step over here. Okay, and this is 180, 360 minus 180 is 180. 1s are 2s are, and we have 11 and so on and so forth. And this is your answer.